Hello students, in your exams, in maths, theorems is also a very important part, and every time you have to prove something, many students think that it's difficult. So what I've thought is I'll divide into parts and do some important theorems, discuss with you some important theorems. So let's start with the video theorems. Before I start, my name is Santanu Das and I've been teaching from the last 27 years. And here I will try to make the concepts as simple as possible for you. So let's start with the theorems. I've already written two theorems on the board. The first theorem is theorem of an angle bisector of triangle. So what does this triangle theorem state? The bisector of an angle of a triangle divides the side opposite to the angle in the ratio of the remaining sides. So how to do this? Okay, so in the exam they will ask you, either they will say prove theorem on angle bisector of triangle, or mostly they give you the statement, and understanding the statement you have to write the given and then you have to prove the theorem. So what is the given? So there's this triangle, I'll say, let's consider it as ABC, and the bisector of an angle of a triangle, suppose this is bisected at point D, angle A is bisected at point D. The bisector, so what is given is ray AD bisects angle ABC. Okay, and so we have to prove. Let's see what they have written. The bisector of an angle of a triangle divides the side opposite. Now, which is the side opposite? This is the side opposite. Divides the side opposite to the angle in ratio of the remaining sides. Means you mean to say BD upon DC, that is the side opposite which has been divided into their remaining sides, means that's equal to AB upon AC. Now how do we prove this? So for this, first of all, we have to do a little bit of construction. What's going to be the construction? We have to take a point E such that AD is parallel to CE. Take point E such that, first of all, this will come in one line, that is, they are collinear points, B dash A dash E. Whenever we write it like this, it means they are collinear points, B dash A dash E, and ray AD is parallel to segment CE. So this is a little bit of construction that we have to do to prove the given statement. So how will you prove it? Let's start with the proof. First of all, we have said that AD is parallel to CE. Therefore, we can use the BPT as AD is parallel to CE. Reason is, by construction, in geometry and in proofs, every statement you make, you should write the reason. So AD is parallel to CD. Therefore, what we can say is BD upon DC should be equal to BA upon A, that is a BPT. When two lines are parallel, this upon this should be equal to this upon this, by BPT, basic proportionality theorem. Now, see what we had to prove. We had to prove BD upon DC, which we have already got, and AB upon AC. AB we have also got. We just want, instead of A, we want AC over there. How do we do it? Okay, so first statement, you see, AD is parallel to EC. The first statement, let me write it as angle BAD is congruent to angle CAD, that is given that ray AD bisects BAC, so BAD and this angles are equal. Next statement, what we can say is AD parallel to CE and AE as transversal. AE as transversal. So what can we say is, if AD is parallel to CE, CDC, and this is the transversal, then this angle and this angle should be equal because they are corresponding angle up. So angle BAD should be congruent to angle CEA, corresponding angles. Next, again AD is parallel to CE. AD is parallel to CE, and this time I'm considering AC as the transversal, and AC as transversal. In that case, this is a transversal angle, this is a Z, so this angle and this angle should be equal. Angle DAC should be congruent to angle ACE, that is alternate angles. I'll make a separate video on the types of angles in parallel lines. So these are alternate angles. So what has happened is, from this three statement you see, therefore, see, first we wrote these two angles are equal. So just assume, let's take some value. So if this is 30 degrees, this should also be 30 degrees. And in the second step, I said this angle is equal to this angle. So if this is 30, this should be 30. And in the third step, I said this angle is equal to this. So from this, if this is 30, or because they are already 30, 30, so this should be 30. So from these three statements, what we can say is these two angles are equal. Therefore, what can we say is angle AEC is congruent to angle ACE by statement number 1, 2, and 3. Now, when these angles are congruent, that means those two sides are congruent. That means those two sides are congruent. AC is equal to AE. Converse of isosceles triangle theorem, and therefore what can we say is, see, we already had BD upon DC is equal to BA. BA can be same, BA, let's keep it as BA only. BA upon, instead of AE, I can write it as AC. This is from statement number, from this statement and from 5 number statement, from statement number 5. And that is what we needed to prove. BD upon DC, AB and BA is the same thing, BA upon AC, proved. So this is how we have to prove theorem of an angle bisector of triangle. The next one is theorem of areas of similar triangles. What does it say is that when two triangles are similar, let's draw two triangles. This is one triangle, ABC. This is another triangle, PQR. So what is given to us is triangle ABC is similar to triangle PQR. Okay. Then the ratio of the areas, then we have to prove the ratios of the areas, that is area of triangle ABC upon area of triangle PQR will be equal to the ratio of the squares of its corresponding sides. That means AB square upon PQ square is equal to BC square upon QR square is equal to AC square upon PR square. This is what we need to prove. So how will we prove this? Again, for this, we need to do a little bit of construction. That is, draw segment AD perpendicular to segment BC and segment PS perpendicular to segment QR. Okay, let's start now. So proof. How to prove it? First of all, they have given to us triangle ABC. Let us give this numbers. Triangle ABC is similar to triangle PQR. That is already given. Therefore, what we can say is AB upon PQ is equal to BC upon QR is equal to AC upon PR CSST, corresponding sides of similar triangles. So if I square them, so what I'm going to get is AB square upon PQ square is equal to BC square upon QR square AC square upon PR square. On squaring, I'm just squaring the whole thing, so then they will also be equal. Okay, now let's start with the property. Now let's consider also third number. Also, angle ABC will be congruent to angle PQR because CAST, that is corresponding angle of similar triangles. First of all, the sides are proportional and the angles are congruent. Angle ABC will be congruent to this angle, PQR. Now what we'll do is, let's consider triangle ABD. Consider triangle ABD and triangle PQS. In that case, what do we get? Angle ABD is congruent to angle PQS from statement number 3. See, ABC and ABD is the same angle with different names. You call it ABC or angle ABD, it's one and the same thing. Okay, so that's the first thing. And angle ADB is congruent to angle PSQ. By construction, we constructed two perpendiculars by construction. Therefore, what can we say is triangle ABD is similar to triangle PQS by AA test of similarity. Because two angles are congruent, therefore those two angles are similar. So we can write the property AB upon PQ will be equal to BD upon QS is equal to AD upon PS. Same thing. Let us give this number 6. CSST, again, as the triangles are similar, we can say that the sides are proportional. Now see statement number 2 and statement number 6. AB and PQ is here also, AB and PQ is here also. So basically we can say all these are proportional, that is AB upon PQ should be equal to BC upon QR should be equal to AC upon PR, and also this is also AB upon PQ, so it's already written, is equal to BD upon QS is equal to AD upon PS. All the sides will be proportional. So let's rub this off. So now what we'll do is area of triangle ABC upon area of triangle PQR can be written as, now areas are base into height, actually half base into height, but half will get cancelled. So base into height means BC into AD for area of triangle ABC, and for triangle PQR we can write it as QR into PS. Now BC into QR will keep it as it is, but AD upon PS, as all these ratios are equal, so instead of writing AD upon PS, can we again write it as BC upon QR, which will be equal to BC into BC will be BC square upon QR square. So you see, we have proved one of the parts, that is area of triangle ABC upon area of triangle PQR is equal to BC upon QR square. Same way as BC upon QR square is also equal to AB square upon PQ square and AC square from statement number 2. Therefore, from statement number 2, from 2, we can write therefore area of triangle ABC upon area of triangle PQR can be written as the remaining thing. First one I'll write it, BC square upon QR square is equal to same as AB square upon PQ square and AC square upon PR square from statement number 2, from 2. So hence that is what we needed to prove, proved. So these are two important proofs which you need to prepare for the exams, which are asked in the exams. Okay, and what we'll do is we'll divide the theorem section into two parts. So these are two lengthy proofs and important proofs for your exams, and the rest we'll see in another video. I hope you understood what we have done, and thank you for watching the video.